This video is sponsored by PCBWay. As always, my PCB package arrived pretty quick. All of the boards were properly secured in a proper cardboard box with additional foam padding. For this video, I've ordered a brand new Hades VR index controller dev kit. This board is basically a modified Arduino Nano clone with dedicated pins for all of the buttons and joystick. It uses all of the original components from the Nano board in addition to the wireless module. As always, when you order the boards from the PCBWay, you'll get a minimum of 5 pieces. As you can see in the video, the boards are super high quality, you can easily see all of the traces, and there are absolutely zero mistakes. The blue solder mask color looks absolutely dope as well. Since my board is an Arduino clone, I will transfer all of the parts from the original board to mine. Of course, if you want to solder it completely from scratch, you can download the original Arduino Nano schematics, which will tell you which parts were used. So first thing I'm gonna do is completely cover the board with flags. This will make the soldering way easier. And now I will carefully cover all of the solder pads with solder. And finally, I'm ready to solder all of the parts. As you can see, all of the Arduino parts are now soldered, but I'm still missing parts for the radio module. I think it will be best to clean all of the flags residue first, before soldering the radio. After some careful cleaning, the board now looks way better, which means it's time to solder the radio chip. All of the radio components go onto dedicated pads on top of the PCB. And just like before, I will transfer all of the parts from the original radio module. With all of the parts already in place, the board is pretty much finished. You can now go ahead and upload the Hades VR index controller firmware. Of course, we will also need a lot of tact switch buttons. First, I will prepare the faceplate buttons, since there are only 3 of those. The faceplate buttons connect to those pins right here. You will also need 4 tact switch buttons, 1 for each finger. You don't need one for the thumb, since I will use joystick for that. I will use a thin Kenner wire for all of the connections. As you can see, all of the buttons are now properly connected, but I think that the wires may be a bit too short. The finger tact switch buttons will sit on top of this plastic bracket, which then in turn will be mounted in the main housing. Tact switch buttons will be mounted directly on the plastic piece using self-tapping screws. Now I can say for sure that those blue wires are definitely way too short. Also, there was a slight miscalculation on my end, which resulted in a very pointy ends of screws sticking out from the other side. To fix this, I've slightly redesigned the whole bracket and put some plastic covers for the screws. Of course, it would be way easier to use shorter screws, but I just don't have them. So I've replaced the plastic bracket, and it's still not perfect, but much better than before. Next up is the tracker mount. In order to get a real positional tracking, I will use a single Tundra tracker which works with the Lighthouse base stations. If you don't have one of those, you can also use a regular Vive tracker or even ping pong ball with PlayStation Move service. Tracker installation is super simple. You basically put the tracker on top of the mount and secure it with the provided screws. And now the tracker mount is complete. Now let's assemble the faceplate buttons. This small plastic piece will hold all of the tact switch buttons in place, and plastic buttons will go on top of those. Just like before, I'm using self-tapping screws to hold the tact switches in place. Make sure to get the tact switches in correct position, since one of the buttons is rotated by 180 degrees. In the meantime, I've desoldered all of the wires from the main board, since I want to redo the wiring. This big yellow piece right here is the side cover. It's also the housing for the main board. The main board goes on top of the mounting points and is being secured in place using self-tapping screws. I've just now realized that I will have to take it out and solder the power wires first. To charge the internal battery, I will use my charging board that you may have seen already in my previous videos. I will also use this small 3.7 volt battery, which will give me just enough power to use the controller. I've connected the battery to the charger, and as you can see, there is still some power left inside the battery. I will use those two pins right here to connect the charger board to the USB connector on the main board. Thankfully, I can connect the charger board to those two pins right here. I've also removed a bit of solder mask, which gives me a nice ground pin. After connecting both boards together, I can now use USB-C connector to charge the battery. As you can see, after connecting the USB-C cable, the battery is now charging. Those two pins right here will also be connected to the main board, but this time I will use them to power the controller. With everything connected, I can now push the power button and check if everything's working. As you have seen, the Arduino blinked shortly, which means that it is working. And after that, I've installed the main board inside the side cover. Now let's remove the power button from the charging board. So I've removed the power button and replaced it with the external tact switch. This will make it easier to install the power button inside the 3D printed case. I will add a bit of electrical tape on top of the main PCB to prevent any short circuits. Of course, I've left a small openings for the wire connectors since I will still have to solder those. I will start the assembly by soldering the finger array to the dedicated pins on the main PCB. Next I will grab the main handle, which will house all of the remaining electronics. First goes the joystick. This time I will be using a full-sized one, since I don't have any breakout boards for the smaller one. First I've soldered all of the wires, since I will have to thread them through the opening on the plastic handle. And now I will push the joystick on top of the mounting points. I will use a couple of self-tapping screws with 3D printed washers to secure the joystick in place. And now I will solder all of the joystick wires directly to the main PCB. Now let's install the faceplate buttons. I already have all of the wires soldered, so now I will thread them through the opening on the main handle and solder the other end of the wires to the dedicated pins. And now I will install the plastic face buttons. Those should simply slide into the holes on the main plastic handle. And now I will install the tact switches on top of the plastic buttons. And now the first half of the controller is pretty much done. Now let's install the finger buttons. First I will grab the plastic pieces, which will be pushed inside the holes on the main handle. And now I will install the finger array on the dedicated mounting points. And just like that, the finger tracking buttons are now ready. Now let's install the power button. First I will push the small power button plastic piece into this hole right here. And now I will install the tact switch on top of it. And now the power button is fully assembled. It may fall out during assembly, so just be patient with it. And now I will install the Tundra tracker mount. This piece also serves as a front cover. It will be held in place by two self-tapping screws, which will go right here. Controller looks pretty good so far, so now let's close it up. There's a lot of wires, so I will have to push everything inside and close it while it still is possible. The side cover uses 4 self-tapping screws and you will need a pretty thin screwdriver to get them inside. And just like that, the controller is now finished. If you haven't uploaded the Hades VR firmware yet, now it's the best time to do so. To test the controller, I will use my HTC Vive Cosmos Elite headset. And of course you will also need at least one base station. As you can see, the positional tracking is working perfectly. It works surprisingly well, even with a single base station. And here is the in-game view of the controller. Finger tracking is slightly limited, since you can only close and open each finger, but it's great success nonetheless. Anyway, that's all for today. Thanks for watching everyone, and hope to see you in the next video. And as always, huge thanks to my patrons. See you later and goodbye.